A free-falling object is actually any object which is moving freely under the influence of gravity. So you just have one, um, one, one. Basically, it's force or interaction that dominate the motion of the particle or of the object, and it is the gravity. So the acceleration of an object in free fall is always directed downward. So whenever you have a free falling object, you can immediately write down its acceleration as the downward vector. So it's a vector that points downward, and it is equal to the gravity acceleration. And this does not depend upon the initial motion of the object. So we have three possible cases actually for this case, for this motion. Either the object is dropped, which means it's released from rest, or in other words, its initial velocity is equal to 0, and it could be thrown upward or downward. So in the case when it's dropped, its initial velocity is equal to 0, as you can see in here. For the case where it's thrown upward or downward, its velocity is definitely different than 0. Okay, let's have a look at the case when it's dropped. So in this case, it's actually launched without initial position, without initial velocity, and that means v0 equals 0. So at any time t, we have these two equations that describe the motion of the object. The velocity and the vertical positions. But the vertical position, they are given by v equals minus gt. So that means that the value of v at any time is equal to g times t. And you have a minus sign here to say that your velocity is pointing downward, because our choice here for the vertical axis, so our reference axis, is pointing upward. So the minus sign here, it tells us, or it informs us, that the velocity is a vector that points downward. So in opposite direction with respect to y. And we can also conclude that y is equal to y0 minus half gt squared. This is the case when the velocity is 0 at the initial time t0. Okay. Now, what if it's thrown upward or downward? In this case, v0 is different than 0, and you have to take this into account. So here I replaced those the variables with vectors, because it makes a difference when v0 it's pointing upward. In this case, it's a positive number because its projection on the y-axis is positive. And if it is thrown downward, then the v0 is pointing in opposite direction with respect to the y-axis, and that means that v0 is negative. So this is why we have the vectors in the two equations in here. But again, those are the same equations that we have derived earlier, which is v equals v0 plus gt, and y equals y0 plus v0 t plus half gt squared. So those equations, as you can see, they are the same as we have written in here. The only difference is that we have replaced x with y, because a free-falling motion is a motion along the y-axis, not the x-axis. And we have replaced a with the gravity acceleration vector g. So let's take as an example an object thrown upwards, because here we have to talk about something specific in the motion.